Okay, 3.5, dividing polynomials. We're going to first look at long division, okay? So today's going to be long division, tomorrow's going to be synthetic. So in algebra, polynomial long division is an algorithm for dividing a polynomial by another polynomial of the same or lower degree. We follow the same steps as regular long division, okay? So as a recall from like elementary school, if we had 435 divided by 25, what we would do is we would set up 435 divided by 25. Okay, we would say, okay, how many times does 25 go into 4? None. How many times does 25 go into 43? Well, that's 1. So then what we would do is, because it's going into 43, we would put the digit on top of the 3. 1 times 25 would be 25, and we would subtract these. So 13 minus 5 is 8, and 3 minus 2 is 18. Okay, and then we can go ahead and bring down the 5. How many times does 25 go into 185? Well, if you pattern 25, 50, 75, 100, 125, 150, 175. So I get 7. Okay, 7 times 25, I get 175. And when we subtract these, we get 10 as the remainder. Okay, so we're going to do the exact same thing today regarding long division, but we're going to do it with polynomials. So I'm going to state this, and we're going to use this at the end of all of our questions. Okay, the result of a division of a polynomial can be written one of two ways. Okay, so the function divided by like the divisor results in the quotient and then the remainder, but it's the remainder over the divisor because it's a fraction of the original. Okay, I don't use this one very often. We're going to focus on this one. Our function is going to be some quotient times some divisor, right? So if we were to like take, say, the two brackets with numbers in them, right? X squared, X, and then a constant, and we were to expand it and then add the remainder, we should be able to get the function. Like it should expand to the function. I like this one because like, see how this is QD plus R? Well, I think of like DQ, like Dairy Queen. Dairy Queen plus R. That's how I memorize this. So this style shows the fraction cleared from the denominator. Okay, and then these two are called division statements. We are going to use this one. Example 1, divide the following and write your answer as a division statement. So we have this cubic function, x cubed minus 5x squared minus x minus 10. And we're going to divide that by this binomial x minus 2. So we can go ahead and write x cubed minus 5x squared minus x minus 10. And that's going to be divided by x minus 2. Okay, so we're dealing with a binomial here. So we're going to deal with the first two terms. So what times x is going to give us x cubed? Okay, we're going to have to pull in exponent laws here. X squared times x is going to give us x cubed. Okay, as a recall, x to the a times x to the b is going to be x to the a plus b. We're going to add those exponents. Okay, but then we have to finish it. X squared times negative 2 is going to give us negative 2x squared. So remember, because this is a binomial, if we put a subtraction sign here, we are going to subtract them. We have to subtract not only the first terms, but also the second terms. So the first two terms should be identical. They should just cancel out. If not, you did something wrong. Now we have negative 5x squared minus negative 2x squared. Okay, so what I get is essentially this is negative 5x squared plus 2x squared. I get negative 3x squared. Okay, bring down the negative x, and then we do it again. What number times x is going to give us negative 3x squared? So of course we're going to have to do the negative 3. And then what times x gives us x squared? Well, x, right? X to the 1 times x to the 1 is going to give us x squared. So negative 3x times x is going to give us negative 3x squared. And negative 3x times negative 2 is going to give us 6x. And now we subtract. So these two terms are the same. We cancel them out. Now we get negative 1x minus 6x. I get negative 7x. Okay, so now we're going to bring down the negative 10. So again, we're thinking what times x? So we're saying what times x is going to give us, and we need this leading coefficient here, negative 7x. So we know that the x has a 1 on it. So think about it. What number times 1 is going to give us negative 7? Well, that's going to be negative 7. And then what variable of x, if any, times x is going to give us x? Well, we won't be able to have one. We won't have a variable because like a constant times the x is just going to give us like the constant with an x on it. So we're going to go negative 7 times x, negative 7x, and negative 7 times negative 2 is going to give us positive 14. And we're going to go ahead and subtract those. The first terms always cancel out because they're identical. And now we have negative 10 minus 14. So I get negative 28 as the remainder. Okay, and finally, we're going to do division statement. So our division statement's f at x equals d at x, q at x, plus the remainder. Okay, so our f at x is the original. So we just sub in x cubed minus 5x squared minus x minus 10 equals, okay, the divisor and the quotient are going to be this and this. So let's go x squared minus 3x minus 7 times x minus 2. And then we're going to add the remainder, which is negative 28. And that's it. All right, B. So we have x cubed minus 28x minus 41 divided by x plus 4. So let's take a look at this note. The dividend does not contain an x squared term. It's essentially saying plus 0x squared. In this case, you have to add it in. Okay, and then tomorrow when we do synthetic division, we also have to add it in there. Okay, so we're going to have x cubed minus plus 0x squared minus 28x minus 41. And then that's going to be divided by x plus 4. So up here, we need a number that is going to give us, like when multiplied by x, is going to give us x cubed. Okay, so what times x is going to give us x cubed? Well, we know that this is x to the 1, so we're going to have an x squared so that these two add up to x cubed. So this is going to be x squared. The coefficient here is just 1, and here's just 1, so we don't have to do anything with the coefficient. So x squared times x is x cubed, and x squared times 4 is plus 4x squared. Now we subtract. Those go away, and 0 minus 4 is going to be negative 4x squared. And then we bring down the negative 28x. So what number here is going to multiply by x to give us negative 4x squared? So what number times x is going to give us negative 4x squared? So we have to look at both the variable and the coefficient. So the coefficient here is 1. So what times 1 gives us negative 4? Well, negative 4. And x to the what times x to the 1 is going to give us x squared? Well, x to the 1. Right? Because we have to add those two exponents. So we have negative 4x. Negative 4x times x is negative 4x squared. And negative 4x times 4 is negative 16x. Okay. The first terms cancel. And the second terms, negative 28 minus negative 16, I get negative 12x. And go ahead and bring down the negative 41. Okay, so what number times x is going to give us negative 12x? So what number times x is going to give us negative 12x? Well, the x is already accounted for, so we don't need another x term, like x in the term, but the coefficient 1 would have to be multiplied by negative 12. So our number up here is negative 12. Negative 12 times x is negative 12x. And negative 12 times 4 is negative 48. Okay. So since the first two terms are identical, we can just cancel them out. And then we have negative 41 minus negative 48, and we get 7. Okay, our division statement is going to be f at x, so this is the long one, equals, remember it's dq plus r, so it's going to be x plus 4, that's actually the divisor, should have put that first in the last one, but that's okay, times x squared minus 4x minus 12, plus the remainder, which is 7. Okay. As a reminder, the division statement, if you were to expand all of this, add the 7 in, these are going to be equal. Okay, so now we have 2x cubed minus 3x squared minus 8x minus 3. Okay, this time we want to divide it by 2x plus 1. So a little bit different because this divisor has the leading coefficient with an a value of 2 instead of 1. Okay, so we're going to think what number times 2x is going to give us 2x cubed. Okay, so not bad this time because the 2's are already satisfied, so our coefficient's 1. So we know that we need x squared and then x1 to give us x cubed. So let's put an x squared here. X squared times 2x is going to give us 2x cubed. And then x squared times 1 is going to give us x squared. Okay, so subtract these. These two are identical, they just cancel out. And we have negative 3x squared minus 1x squared, so we get negative 4x squared. Okay, bring down the negative 8x. Now, we're thinking what number times our 2x, right? What number times 2x is going to give us negative 4x squared? And guys, this is just on the side of your paper, or like you could do this in your head. Depends on how comfortable you are with it. So what coefficient times 2 is going to give us negative 4? Well, negative 2. What variable times x is going to give us x squared? X. So we'll put a negative 2x here. Negative 2x times 2x is negative 4x squared. Negative 2x times 1 is negative 2x. Okay. The first two terms cancel out. And then we have negative 8 minus negative 2. So we have negative 6x. And then bring down the negative 3. All right, now what number times 2x is going to give us negative 6x? Well, the x's are already good to go. We have x and x. And then we just have to take a look at the coefficient. So we have a 2 and a negative 6. So what times 2 will give us negative 6? Well, I get negative 3. So negative 3 times 2x is going to give us negative 6x. And negative 3 times 1 is going to give us negative 3. So check this out. These two are identical. They cancel out. These two are identical. Those cancel out. We have 0 remainder. Okay, let's write the division statement, then we're going to talk about this. So our division statement is 2x cubed minus 3x squared minus 8x minus 3 equals 2x plus 1 times x squared minus 2x minus 3 plus 0. Okay, the expanded form here, which is f at x, our divisor, so what did we divide it by? Okay, this is d at x. Our quotient is like your answer, right? A quotient is the answer to any division statement. And then plus the remainder. Okay. So I want to note, first of all, we don't actually have to put plus 0 here. Okay? Obviously plus 0, just simplify it, leave it out. So for this division statement, when we write this, you'll notice that Q and D, sorry, the exponent values on Q, D, and R are always less than the degree of f at x. So f at x is degree 3. This binomial, like our divisor, is degree 1, and then our quotient is degree 2. Okay, so you notice these two are less than the original. Now, I also want to touch on this. In the event that we have no remainder, and this is what we just experienced, we have remainder 0, what happens is the polynomial is actually successfully factored. So we can say that 2x plus 1, we can say like 2x plus 1 is a factor of f at x. That's what that means. Example 2. One factor of this function, f at x equals 6x cubed plus 5x squared minus 16x minus 15. So one of the factors is this, 2x plus 3. So number 1 is asking us to determine the other factors. So here's the thing, like up until this year, I mean, we could use factor theorem, but we haven't gotten into that yet. So let's go ahead and divide this function by 2x plus 3. Okay, so we're going to go 2x plus 3, and we're going to go 6x cubed plus 5x squared minus 16x minus 15. Okay, because up until now we factor, but we generally are comfortable factoring with an x squared term, right? Like a quadratic. So let's factor out the 2x plus 3. We're going to be left with a quadratic. All right, so what number times 2x, the other side of the paper, is going to give us this leading coefficient, 6x cubed? Okay, so what times 2 gives us 6? Well, that's 3. And what times x gives us x cubed? Well, that's x squared. So 3x squared times 2x is going to give us 6x cubed. Well, that's exactly what we wanted because these are going to cancel out in the next step. Okay. So 3x squared times 3 is going to give us 9x squared. So 5x squared minus 9x squared is going to give us negative 4x squared. Bring down the negative 16x. So what times 2x is going to give us the negative 4x squared? Okay, so let's look at the coefficient. What times 2 is going to give us negative 4? Well, negative 2. Let's look at the variable. What times x is going to give us x squared? Well, x. So negative 2x times 2x gives us negative 4x squared. Perfect, because those are identical. They're going to cancel out. Now, negative 2x times 3 is going to give us negative 6x. So negative 16x minus negative 6x is going to give us 10x. Bring down the negative 15. Now, what times 2x is going to give us 10x? Well, that's just 5. Okay, the x is already accounted for, so plus 5. So 5 times 2x gives us 10x. 5 times 3 gives us 15. Sorry, negative 16x minus 6x is negative 10x. So this is going to be a subtraction. So negative 5 times 2x is going to give us our negative 10x. And negative 5 times 3 is going to give us our negative 15, which works out because these two are identical, these two are identical, and then we get remainder 0, which is exactly what the question tells us. So we know that because the remainder is 0, we know that 2x plus 3 is a factor. The question also tells us it. However, we actually needed to divide by 2x plus 3 in order to get what's left over. So what's left over is this trinomial here, 3x squared minus 2x minus 5. This question wants us to determine the other factors. Well, we know from grade 10, if we have a trinomial, we multiply AC. So what two numbers multiply to negative 15 and add to negative 2? So multiplies to 15, 1 and 15, 3 and 5. If we put a negative on the 5, it's going to add to negative 2. So decomposition, we're going to break down this middle term. So copy the first term and the last terms. We're going to decomp this middle term into plus 3x minus 5x. And now we're going to common factor 3 times. So common factor here, a 3x. And then we're going to common factor here a negative 5. Okay, so 3x, what's left over? X plus 1. Factor out a negative 5, what's left over? X plus 1. Now, 3x minus 5, x plus 1. Those are our other two factors. So number 1 is done. Determine the other factors. We're good. This is the other factor, and then this is the other factor. Now, the question says find the zeros. If you actually think about it, our function f at x can be written in fully factored form, 2x plus 3, 3x minus 5, and x plus 1. So that's fully factored form. Now, all we have to do is we have to branch each of these factors off and determine when each of these factors equals 0. Okay, so bring over the 3. We get 2x equals negative 3. Divide both sides. We get x equals negative 3 over 2. Now, bring over this negative 5. We get 3x equals 5. Okay, divide out the 3. We get x equals 5 over 3. Bring over this 1. I get x equals negative 1. Those are our 3x intercepts.